this is the Instron I'm using for the elongation and break for my XLPE straw samples. And here is the extensometer camera, which goes with the Instron and control. Both of them are controlled by the computer here using the software Blue Hill. So the camera here can accurately record the strain of my samples during the elongation and break test. According to the standard of elongation and break test on straw geometry samples, we need to use the end tabs to protect the sample from the Instron clamps. In the standard, the end tab that is used is in this geometry, marked as number 1. But some practical issue will be caused by using this geometry end tab. It is that when the end tab is tightly gripped by the Instron clamps, some cracks will be introduced here at the contacting point of the inner edge of the end tab with the sample. So when cracks are introduced at the contacting point during the elongation and the break test, the sample will break at the contacting point instead of in between the gauge, which leads to the failure of the test. So what I did was to design the end tab into this geometry marked as number 2. In this geometry end tab, it is a curve at one edge of it. When you grip the end tab with the Instron, you only tightly grip this part and leave this part out so that no cracks will be introduced using this end tab, and to make sure that the sample breaks down at between the gauge instead of the contact point. To prepare for the test, the first thing you do is to clean the sample surface. I clean the sample surface with acetone. Okay. According to the standard, the minimum sample length for this test should be 50 mm for these geometry samples. So what I have here is 3 straws at the length about 100 mm. This length is 106 mm. This is the middle point. So I'm cutting the samples into halves. So now I have 5 samples for the test. The principle how the camera works is that you mark 2 points on your sample, and the camera catches these 2 points and then record their position during the test. If you do not flat the sample, yes, the camera can successfully catch these 2 points at the beginning. However, during the test, the sample gets narrower and narrower while being stretched, and eventually it sometimes happens that the points gets in contact with the black background of the camera, so that the camera can no longer recognize this as a point. So the camera loses catching the points, and then you will not be able to record the strain of your sample anymore. So the measurement is failed. So that's why I flat the sample to make the sample wider so that this situation do not happen. Well, this is the way how I flat the sample. So these are the 5 samples after being flattened, which is the right word. I'm not sure. Okay, so it's not flattened a lot, but a little bit. Now I need to mark 2 points in the middle of the sample. The one thing you need to pay attention to when marking the points is that you don't want the points to be too big, otherwise the camera will fail to catch the point during the elongation break test because of the sample gets narrow, and for the reason that I have just mentioned. Also, you don't want the points to be too small, otherwise when the ink, there is too little ink in that point, and when you stretch it, the point gets looser, and somehow the camera still fails to catch the point. That's my experience after many tests. So I would suggest a kind of medium-sized point and put as much ink in there as possible. Okay, these are the 5 samples that are marked points, and let's wait a little bit until the points get dry, and then we'll start the test. catch 不到点，它会闪着。Make sure the points can be captured by the camera, then we will tighten the grips. Okay, the test gets started. Okay. Alright, this is what it looks like in the test.